In this video, we're going to be talking about simple harmonic motion. Now, one illustration of the relationship between sine waves and harmonic motion is the wave motion that results when a stone is dropped into a calm pool of water. The waves move outward. So here would be if we had dropped the stone here, right? So let's make that a different color. So we had dropped the stone. Notice that the waves move outward in roughly the shape of a sine or a cosine, as we see here in our example. So as an example, assume like you're fishing and your fishing bobber is attached so that it does not move horizontally. It only is going to move vertically. As the waves move outward from the dropped stone, your fishing bobber will move up and down in a simple harmonic motion, as shown here. Let's go ahead and let's do an example. So we're going to consider the equation for simple harmonic motion. D equals 6 times the cosine of 3 pi over 4 times t. And we're going to find the following. We're going to find our maximum displacement, the frequency, the value of d when t equals 4, and at least positive value for t for which d equals 0. So let's begin by finding the maximum displacement. So the maximum displacement is the amplitude. Now recall from before that our basic simple harmonic formula is d equals a times the cosine of wt, where a can be found for our amplitude. So our amplitude equation is the absolute value of a. So in this case, our amplitude is going to be the absolute value of 6. So we can say that our amplitude is 6. Therefore, we're able to say that the maximum displacement is 6. The frequency, to find our frequency, we're going to want to use our frequency equation. And our frequency equation is F equals W divided by 2 pi. So we can see here that we have an A value of 6 and we have a W value of 3 pi over 4. And so we can plug that into our frequency equation. So here we're able to say that frequency equals 3 pi over 4 divided by 2 pi. Clean that up a little bit. There we go. And so what we're looking at here is 3 pi over 4 divided by 2 pi over 1, and we'll keep change flip, leaving us with 3 pi over 4 times 1 over 2 pi. Our pi's will cancel out, and that will leave us with a final answer of 3 over 4. And so we're going to be able to say, or rather it should be 3 over 8. 4 times 2 is 8. 3 over 8. And so we're able to say here that the frequency is 3/8 of a cycle per unit of time, whatever unit of time it is that we're using. And it didn't tell us, so this is what we're going to go with here. Next, we want to find the value of d when t equals 4. So remember that our equation is d equals 6 times the cosine of 3 pi over 4 times t. And so we're simply going to replace our t with a 4. And so we'll have d equals 6 times the cosine of 3 pi over 4 times 4, where we've plugged our 4 into that space. which is then going to give us that d equals 6 times the cosine of 3 pi. And we're able to say that because this is like saying 4 over 1, which means our 4's will cancel out. The cosine of 3 pi, equals a -1. So we're then able to say that d equals 6 times -1, or in other words, d equals -6. So we're able to then find the value of d when t equals 4. Lastly, we're going to find the least positive value of t for which d equals 0. So we're going to take our equation, d equals 6 times the cosine of 3 pi over 4 times t, and we're going to take the d out, and we're going to replace the d with the 0. We're going to replace it with the 0. And here we're going to go ahead and we're going to solve. So we're going to start by dividing both sides by 6. Well, 0 divided by 6 is still a 0. From here, we're going to use our graph to help us. So we'll pull up our graphing calculator, and we'll go to mode and make sure that we are in radians. And we'll go to our y equals, and we'll plug in our equation. So we're going to go ahead and we're going to plug in the cosine of 3 pi over 4 times t, or in this case x, which is fine as well. And then we're going to go to our window, and let's graph this from 0 to 2 pi. And we'll go by scales of maybe pi halves. And for our y minimum, let's have a value of -10 and a maximum of 10. So we're going to go ahead and we're going to graph this. So it looks like we don't really need 10. So let's go back to our window and let's change this to maybe a -5 and a 5. We'll graph that, and that looks a little bit better. So our lowest value, or least positive value, is going to be this value right here, where our graph crosses the x-axis, that piece right there. So we'll go to second, calculate. We'll calculate the 0. So we're going to want the left bound, so we'll come all the way over to that piece. So we're on the left side of that, so we'll hit enter. Then we'll go to the right side, and we'll hit enter, and then calculate it. And here we're going to have a 0.666 repeating 6, or a 2/3. So here we're going to be able to say that our t value is going to equal 2/3. And so we have that the least positive value of t for which d equals 0 is 2/3. And we're finished.